Thank you. Well, I'm here to present about Industry 5.0 solutions for compressed air systems and the benefits that the end user can experience by deploying Industry 5.0 in their facility. A short introduction about us. SYSTEL is an Indo-Danish venture started in the year 2002, and our mission is to simplify compressed air management. So for the last 18 years, we have worked across companies in Asia Pacific. So over 1,600 compressed air projects have been implemented by us. And with these projects, we have a combined energy saving of over 50 million megawatt hours in the compressed air systems alone. And we were probably the first company to get certified under ISO 11011, which is the governing standards for compressed air assessments and compressed air management. And we are also the first company to bring in Industry 5.0 solutions to compressed air systems. So we might be aware that energy is the major chunk of the life cycle cost of a compressor. But what largely is overlooked is on the sustainability side of it. So here I would present you that an 100 HP compressor in a year consumes close to 648,000 kilowatt per hours, and converting it at 7.5 rupees per kilowatt hour. It is close to 4.8 million rupees. That is the energy cost that has been incurred for running a 100 HP compressor. And this compressor also emits close to 100 tons of carbon. And if it is a water-cooled compressor, then it consumes close to 5.1 million liters of water for its cooling requirement. And it also produces close to 100,000 liters of condensate. So running a additional capacity of compressors not only wastes energy, but it also has a significant impact on the environment here. You should be aware that compressed air is one of the most inefficient utility available to the industry, with hardly 10% to 20% of the actual input energy gets into a usable form and reaches the point of use. So there are multiple losses in a compressed air system, with the heat being 40 to 50% is the usual energy loss due to heat, and 20% is due to leakages, artificial demand, misuses, and distribution losses usually contribute somewhere between 15 to 20%. So out of the 100% electricity that has been fed into a compressor, hardly 20% gets converted and reaches the actual point of use. So given this as the case, I've broadly classified some of the puzzles that comes into managing a compressor system. The first one being how much air is actually produced. So this is a debatable subject since there is a big misunderstanding in the end user perspective of the compressor's rated capacity and the manufacturer's perspective of the compressor's capacity. So when you want to have 1,000 CFM, when you procure 1,000 CFM capacity of compressor, usually it has been assumed from the end user side that this 1,000 CFM is going to be pumped into the facility, or it's going to pumped into the pipelines here. But when the manufacturer claims to have 1,000 CFM, he's actually referring to certain standard conditions, which is like 20 degree is the ambient temperature, 0% is the relative humidity, and 1.03 bar is the atmospheric pressure. So any variations in these three parameters is going to lead in lesser delivery outputs of the compressor. And though sometimes the power of the compressor has been measured, hardly in very few cases it is practiced that they have a flow meter to measure what is the actual real air delivery the compressor generates. So when we talk about the specific energy consumption, it is a relationship between the input power the compressor draws in to deliver 1 unit of compressed air. But just by measuring one variable, most of the time, the end users, they end up in higher specific power. So it is many of the installations, they also lack proper metering, so they don't have any clues about how much air is being produced. So usually they go over the nameplate information, but there is no real measurement to quantify how much air is being actually generated in the facility. And the second one is about the requirement part. Like there is a big difference between the actual requirement the plant requires and also the actual consumption that is happening now. So the consumption is an inclusive volume, including your leakages, your artificial demand, and your other form of losses. So many of the cases we see that like scientifically the actual requirement of the plant has not been quantified. So this also leads to a lot of efficiency gap between the supply and demand. And it is also about like the losses. So as I told you, like compressed air is prone to various losses there. So unless that is those are being quantified and the gaps have been identified, it will be very hard for you to maintain a system which has a low leakage or low loss levels. And finally, about the equipment efficiencies, like so this is also highly questionable in many areas where they don't have a metering for monitoring the compressor's specific power or the dryer's pressure dew point or the pressure drops across each treatment or filter equipments. So whether it's like when we don't have answers for the four questions that I raised above, it is going to result in inefficiency. And the one first inefficiency that you're going to experience is higher energy cost, and usually like the specific power can be as much as 30% higher if there is no proper monitoring on the supply side of the system. And it could also lead to high maintenance cost due to higher operational hours of the compressors and allied equipments. And higher system pressure could also lead to leakages, and leakage levels of 20 to 30% is very, very common that we see in the industries here. And frequent breakdowns. So they to avoid the production deteriorations, like usually they go by the identical capacity of backup compressors. So that would also be a waste in terms of working capital is concerned. And another drawback of this is like you will also be ending up with having a compressed air with a very poor quality. So that could create a lot of rusting, scaling in your pipelines, and sometimes even the oil contaminants may affect your production process. Production interruptions due to fluctuating system pressure is another result of inefficiency. And overall, this will result in a higher cost of ownership. So basically, we try to deploy Industry 5.0 to help you overcome your present energy and cost wastages, high greenhouse gas emissions, to an environment where you have a higher operational efficiency, and your ownership cost of the compressed air systems is highly lowered. So this we apply, this we achieve with the systematic and smart improvements. So deploying Industry 5.0, the main concept here is to move from wastefulness to wastelessness. And to just define you about Industry 5.0, Industry 5.0 is an extension of Industry 4.0. So Industry 5.0 empowers people to work alongside smart machines. It's about the smart technology helping humans to work better and faster by adopting advanced techniques like Internet of Things and big data. So it also has it also adds a personal human touch to the Industry 4.0 pillars of automation and efficiency. And the objective of Industry 4.0 is to interconnect machines, process, and systems, whereas Industry 5.0 takes Industry 4.0 to much higher efficiency and productivity. And with Industry 5.0, like the aim is not to supersede humans or replace humans. It is to support the humans to do the work in a much efficient and much productive manner. And we have seen that like there is a very good progress of the industries adopting Industry 5.0 standards. So so far in India, we have around five large corporates who have adopted Industry 5.0 throughout their entire manufacturing plants across India. So our first process in Industry 5.0 starts with baselining your operating data. So with this, we connect our smart IoT based power meters on the compressors and differential pressure pitot tube at your compressor outlets. So these two sensors, they collect in real time what is the actual power that's been consumed by the compressor, and what is the actual air output the compressor delivers. So it consistently and continuously makes a relationship between the input power and output flow, and it arrives at a specific energy consumption. And then like this data are being remotely sent to our smart compressed air management software. So the software has an artificial intelligence program in it. So based on the specific power inputs that the software receives from the compressors, the software can also give you an indication of which is the most efficient compressor combination that you can run for achieving a lower energy efficiency. And the other sensors like the digital pressure sensors, which transmit or which understand what is the pressure drop that is happening across your dryers, dew point sensor to understand what is the actual pressure dew points that you're producing from your refrigerant or from your desiccant dryers. Here another fact is like usually the end user assumes that whatever is displayed in the dryer is actually the dew point. So there is quite a difference between it. So what you actually see in the refrigerant dryer is an evaporative chiller temperature, and that is not the pressure dew point. That in simple terms, like the display what you see in your dryer, it is not taking a sample of your air from the dryer and measuring and indicating the pressure dew point, whereas it is just indicating the evaporative chiller temperature. So having it in a refrigerant dryer, having a dew point in the display shown as like 3 or 5 degree, in real term, it means that the actual pressure dew point is as high as 17 to 20 degrees. And with 17 to 20 degrees, it means that like you are allowing close to 200 grams of moisture for every 1 kilogram of air. So once this moisture enters into your system, there is a lot of tangible effects of it. Like it creates rusting in your pipelines, scaling in your pipelines, it creates pressure drop, and it also damages all the seals of your pneumatic components like actuators, valves and connectors. So these are the major root causes for recurring leaks in your system. So maintaining the pressure dew point at a very low level will ensure that the maintenance of the downstream of the system is considerably lower. And we also have thermal mass flow sensors, which are usually deployed at the department levels and also at the machine levels. So these sensors also collect and transmit the data to our smart monitoring software. So you get a basic dashboard view of the entire, the entire happenings of your entire compressed air system verticals. And with our master controller, it is again an artificial intelligence based controller. So this controller can very tightly integrate the supply with demand. So the controller can bring in the most efficient compressor combinations. It can control your dryers, condensate drain traps. So the objective here is to achieve a low energy rate during your unloading process. So you can also integrate your VFD compressors into it, and the controller can manage the VFDs in a very ideal bandwidth of 65 to 80%, which is the most efficient curve for operating a VFD compressor. And the second, once the baselining process has been done by us, then we start with defining industry-specific goals. So what should be your overall system efficiency in terms of kilowatt per every CFM that's been produced, and what could be the right kind of air quality that will be suitable for your plant in terms of pressure dew point, or in terms of oil vapor content, or in terms of particle concentrations. So for refrigerant dryers, we also help you to ensure that like your dew points doesn't exceed 3 degrees. And if it is a desiccant dryer, then we ensure that like you can achieve a dew point of minus 50 degree and sustain it. And we also go with the amount of permissible pressure drops that can happen across your system. So a best designed piping network should not have a pressure drop of say 0.5 bar from the compressor outlet till the end point of use. And this includes the pressure drops that you may experience with your dryers or your wet and dry filters. And in terms of leakages, we can help you lower your leakages to less than 5% or even to lesser levels if you desire so. And we can also ensure that a proper root cause analysis is done for the leakages, and so you don't develop any leakages, in the near term. And we also recommend having two pressure zones. So one might be for less than 5 bar, another one for pressure requirements above 5 till 8 or 10 bars. So maintaining dual pressure zones will also help you to save significantly in the specific energy of your compressors. And once the baselining is done, once the goals have been designed specific for your industry, then we can also help you to implement the corrections. So we offer a wide range of services, starting from leak surveys, leak repairs, measurements, both temporary and permanent measurements, annual maintenance contracts, and we can also give user specific and industry specific trainings. And we also design greenfield projects. We also design and re-engineer the existing projects. We can do performance validation of the entire equipments like your compressors, dryers, or your filters, and even at the end of production machines. And we also do the baseline audit. So these are basically as a third step of Industry 5.0. We offer our corrective actions for the industry. So this is typically an example of how with a conventional control strategy a compressed air system operates. So usually we put the higher capacity compressors as a base compressor, and what happens for a demand for a varying demand of say 1000 CFM, like the 1000 CFM compressor operates, which is the highest and considered as base. But what happens during a lesser load, say 750 CFM, again the same 1000 CFM compressor starts working with 25% wasting 25% for the unload part of it. So even for a very lower capacity with a conventional control strategy, you don't have the flexibility. So you have to still bring in the bigger compressors, and those compressors will be unloading and wasting huge amount of energy during its unload. So there could be an option of bringing in a VFD compressor, but then like VFD compressors will be most ideal only when they are operating at a curve of around 65 to 80% of their rated capacity. So with our artificial intelligence based master controllers, so the controller can continuously evaluate the compressor's efficiency based on the power input and the flow output the compressor delivers. And to meet out your demand, it can ideally bring in the correct combination or correct capacity of compressor. So you always make sure that like the compressors run at its peak efficiency, and the wastages during compressor unloads is reduced to say less than 2%. So this master controller can be integrated for compressor rooms up to 34 or 32 compressors, or if you have multiple compressor rooms, that it can also be integrated. So overall, with this, with all the data and informations that has been collected from various sensors, you have the software provides you an dashboard and a snapshot view of the cost that you're incurring for generating your compressed air, and what is your system efficiency, what is the power rate, and you get all the trending graphs in real time. And the another one is like you can have threshold levels being defined into the software. So whenever the consumption exceeds your threshold levels, you get an user alert. And you can also assign automated reports wherein you get a quick information about the overall efficiency level of your system. So for the demand side optimization, like we offer sensors which can basically gather the leakages, artificial demand, your misuses in real time, and they also send the feedback to our smart monitoring software. So you get all this information immediately available. So whenever there is an excessive air consumption happening either at your department levels or at your machine levels, whenever the dew points have any variation, whenever some new leakages have occurred, or whenever there is any misuses that's been happening. So all these informations are being captured in our smart monitoring software, and the end users are alerted of this changes. So that's all we have for the session today. So you can always feel free to write to us, so will be